we have a little bit familiarity with arrays already in one or two lab programs, IAnalyze or iPractice programs. You must have encountered use of character arrays. Okay, so this here we are going to learn in detail about arrays. Arrays are fundamentally the data types in C are classified into this diagram I have shown before also when we studied the primitive or basic or fundamental data types in C. So the fundamental data types were character, integer, float, double and void. Now arrays are part of derived data type. There is a spelling mistake here, VED. Okay, so the image actually, so I am not able to edit that. So arrays are part of derived data types. And there is another category called user defined data type. In that structures we will study. Other two we will not study. Okay, here derived data type arrays, pointers we see. Function also we will learn, but we will not categorize it as derived data type. Maybe some authors categorize functions also as derived data type. Okay, let's not worry about that. Basically, so array is a derived data type. Array is as a definition, array is a fixed size sequence of elements of same data type. Fixed size sequence of elements of same data type. Arrays are derived data type, allows to store several data items of same type in a single array. Okay, such things are there. We'll move to practical aspects rather than theoretical. Then later we'll come to theory, so that you have a very good understanding of theory as well as practical aspects. Creates the gives you the idea of how practically these things are used. Then there's a little bit of theoretical things we'll see. So what we are familiar already, we'll take up that. I can create a array of characters. So basically array is a collection of variables, I can say. A single shot creation of a set of variables. If I create something like this, ch, this is this single variable, I can store only one character, right? Now when I create a set of variables in this way as an array, now in this str, which is an array of characters, I can store up to 10 characters. So when you keep 10 characters together, it becomes a string or a text, right? So in C there is no data type, direct built-in data type to store strings, sentences, text content or strings, words. There is no built-in data type. Instead of that, how we manage in C is by creating an array of character variables, or otherwise called as a set of character variables, otherwise called as a character array. Okay. Now generally, now if I change it into int, that means I have an array of int. I will give a different name. Simply array only I'll give. Okay. Now when I am doing, I have an array of integers where I can store 10 integer values. Up to 10 integer values I can store. Now what is the use of creating an array? So in characters array we already saw we can store a name or a string. With a single character I can store only one character in that. Now if I have to store a name, I will have to create so many variables, single individual variables. So instead of doing that, that is not feasible actually. Creating so many variables to store a sentence or a name or something like that. Say char ch1, ch1. So Amit, if Amit is the name, c1 will store a, c2 will store m, c3 will store I. Like that, keep on creating variables is not feasible actually. It is difficult to manage. Instead of that, what we can do is we can create an array. Okay. So this can be used for storing any string or name up to 20 characters. 20 or maximum 19 characters or 20 characters we can store a name or string. Now similarly, we can create integer arrays also. That means we can store in one shot we create 10 integer variables and we can store 10 integer values in those variables. That is what integer array is doing. Okay, what is the use? The use is that we can store large amount of data in our program and process those data and create whatever output we want to generate. Okay, take the example like you want to find the largest of 10 numbers. Find the largest of 10 numbers. Then these numbers are entered by the user. Okay. And a crude and very crude way of doing it is create 10 individual variables int n1, n2, n3, etc. up to n10, 10 individual variables and get all the values from the user, scanf, then ampersand n1, ampersand n2. Like that you do. It is a crude way of doing it. It is generalized, not generalizable. Later, if you want to find the largest of 20 numbers, it is not possible. Again, you will have to rewrite the program 20 variables of integer type. So instead of that, what we do is we create an array. I can give any name to array. This is like just like identifier. I can give any name to an array. Okay. So once I create an array like that, we have, it is as good as having 10 variables, 10 variables of integer, 10 integer variables. Okay. Now we'll go back to the slide. I have created an integer array of size 5. Okay, the general syntax for creating is like this: data type, name of the variable, and in square bracket the size. Now when I create this, the example is here, int a of 5. So when I do this, in the computer memory, such an array is created. You know, the computer memory is a sequence of bytes. So here sufficient space for 5 integer variables are allocated. Sufficient space for 5 integer variables are allocated. And each of these individual variables we refer using the name of the array followed by a square bracket and a number in that. And numbering is called indexing of the array. The number we use in the square bracket, we call it as indexing of the array. So when I am saying, and the indexing starts from 0. 0 is the minimum index we can use for an array. So A0 means the first integer variable. When I put A0, it means the first integer variable. We know that an integer in memory takes 2 or 4 bytes. Assume that my machine is a 32-bit machine. A0 is, this is actually the first element, the first cell you are finding here. This is actually 4 bytes. Because I have to store an integer. Sufficient memory is required for an integer. Now next element in the array or next integer variable, we can refer it as a of 1 or a1. A in square bracket 1. Next is a2. Next is a3 and a4. So if the array size is 5, I use the indexing from 0 to 4, that is 5 minus 1. A of 5 is not part of this array. Here when I say 5 means the size of the array, that means 5 elements. It doesn't mean that I have an element A of 5 in my array. Okay, my indexing starts from 0 and ends at 4. So in that way, first element, second element, third element, fourth element, fifth element. So 5 elements are there in my array. So if I create an array like that, I can store 5 integer variables in one stretch. 5 integer variables in one stretch. Now if I want to create space for storing 100 elements, I can just change it. I can change it to A of 100. That means using the indexing values 0 to 99, I can store 100 elements. At 0, first element, and the last element will be at index 99. I can use 0 to 99 indexing. Similarly, A of 0, first number, and A of 4 fifth number, A of 99 100th number. I can use that way. Okay. Any doubt is there in between? Just stop and ask, unmute and ask. Okay. Now here when I am doing, I am not putting any data into the array. So I will just revert it back to 5. I am not putting any data into the array. Now once I create the array, I can directly put data into that array using the indexing. So here is an example. I created an array. When I create, it's empty, or there will be some garbage random values. Okay, in the computer memory, always there will be, whenever it is on, there will be some garbage values. Okay, so which will not be of any use to us. For our program, we have to store some numbers. Now after creating the array, I want to store some numbers because I am creating array to store data. So what I am going to do is A of 0 equal to 5. When I do that, 5 will be stored in this location. Okay, after this is executed, after the first statement is executed, 5 will be stored here. After A of 1 is equal to 10 is executed, 10 will be stored here. Okay. I shouldn't have deleted it. A1 10 when I am doing, 10 is assigned. A2 equal to 15 when I am doing, or when it is executed, 15 will be assigned into this, stored in this array in the third location as the third element. A of 3, fourth element in the array, 20 will be assigned. Okay, A of 5, A of 4, 25. A of 5 is not a member of this array. That is, when you create A of 5, that 5 means size of the array, and the elements are A of 0, A of 1, A2, A3, A4 only much. A of 5 is not a valid location, okay, in that array. So 5 elements we are able to store. Similarly, if I can create a floating point array, similar manner, floating point array, and initialization I can do similar manner. But this way of initializing an array is tedious, because if the array size is 100 elements, I cannot do this. A of 0, B of 0. Unnecessarily my program will be very large. Moreover, I don't want to assign data like this. I want to get the data from the user and directly store into B of 0. In that case, this way of initializing or assigning data, storing data into the array is useless or not very feasible. If the array is very small and you are not taking any input from the user, directly assigning here, that time only it is useful, but generally it is not useful. Okay, so we need some other better mechanism to store elements into the array. Okay, so far is it clear? Arrays. Now instead of float, I can create double type. I can create character type also. Okay, integer character array already we know is for storing, we created string, we created, then integer, float, double we can create. Okay, now there is some theoretical topic in the sense how to initialize. There are two ways of initializing means storing data into the array. Okay, you create an array, storing data into the array. There are two ways. One is compile time initialization and runtime initialization. Compile time means when we are typing the program and compiling it, that time only we initialize the array content. So what I am doing here is compile time initialization. When I am writing and compiling the program, that time only I know that what data needs to be stored in the array. Okay, so because of that I am initializing directly, so that comes under compile time initialization. The other one is runtime initialization. This happens when we are directly taking the data from the user. So during compile time, we are not aware what data needs to be stored in the array. So we compile the program, we generate the executable file, then we execute the file and we ask the user to enter the data. So that is called runtime initialization. Okay. And practically most of the time we will be doing runtime initialization in case of arrays, because we want to get the data. Normally most of the programs will take the data from the user rather than do initializing within the code. Okay. So far we have seen, we have taken largest of 3 numbers, we have taken the data from the user, or sum of first 10 numbers, we have taken the maximum value from the user. So runtime initialization is going to happen most of the time. Still, you are expected to know the way of compile time initialization. One we already saw. If we know the values, individually take up each element in the array, the b of 0, b of 1, etc., and assign it. The other way of compile time initialization is this: using curly braces, directly assign a of 3 and assign it directly using curly braces. So my array a of 3 means 3 elements are there in the array: a of 0, a of 1 and a of 2. Then when I am doing it, 5 will be stored in a of 0, 10 will be stored in a1, 15 will be stored in a2. The same thing happens in the case of a floating point array. Float b4 equal to 5.100. So the output will look like this. This is a logical representation or a visual representation of what happens in the memory, how it is stored in the memory. Okay. And remember that each of these elements are of 4 bytes since they are integers. In case of character array, each of the elements will be of 1 byte. Float, it will be 4. Double, it will be, each of the elements will be of size 8 bytes, like that. Depends on what is the basic type of the array. Say float is the type of the array, so each element will be of that size. Int is the basic type of the array, each element will be of size of an integer, typically 2 bytes or 4 bytes. Okay. So this total size of this array will be now, so if each individual element is 4 bytes, total size of the array will be 12 bytes. 4 plus 4 plus 4. Okay. Any question is there, you please ask. So compile time initialization, the simplest syntax is like this. Now some more variants actually. I have int a3, that means a 3 element size array, but I am initializing only 2 elements. So what will happen is the third element will be automatically initialized to 0 by the compiler. Third element will be automatically initialized to 0 by the compiler. Similar thing happens for floating point or double also. The first 2 elements I am initializing, third and fourth element will be automatically initialized to 0. Okay. These are a little bit of theoretical things which you need to remember. Now, what happened? Yeah. Now, runtime initialization is what we normally use. Runtime initialization. So, there, in fact, the strict sense of runtime initialization is taking the input from the user. But instead of that, what we are doing is here we use, instead of using a0 equal to some number, a1 equal to some number, instead of doing that, we use a loop. Now for this indexing, 0 1, we can only use integers here, 0 1 2 3 etc. Now I am using an integer constant, but it can be an integer variable also. So if I have a variable I and value of I equal to 0, if I put I here, it is as good as putting B0. Okay. So what we do normally is use a variable. For the indexing, we use a variable. We call it as indexing variable. And we keep changing the value of the variable depending on where we want to store the data. So if I want to store at second location, I will the indexing variable, I will change it as, suppose I is the indexing variable, I will change it as 1, I equal to 1, and then b of I will do. Then if I want to store at third location, I will make I is equal to 2, and I will put b of I equal to, like that. I can access every element in the array using either constant value of the constant index value, or store that constant index value into a variable and access the element. That is what is done here. So we already studied loop, just now we finished. So what I am doing is I is equal to 0, I less than 3, I plus plus. So how many times my loop is going to execute? How many times this will be executed? For I is 3 times it will be executed. I is equal to 0, I is equal to 1, I is equal to 2. When I becomes 3, 3 less than 3 is false, we will not execute. Now I will take the variable I will take value 0 first time. So that time a of I means a of 0. I am assigning 5. We get 5 here. Then next time I is incremented, 1 less than 3 is true. A of 1 will be 5. So I am assigning here. Then next time I will be 2. A of 2 will be 5. I am assigning here. So this is the common format of assigning a variable or assigning values into. But again, still it is not generalized. I am not taking input from the user. I am directly assigning it here, and every element gets same value. Okay, there is no use with that actually. If I storing the same value in every location doesn't matter. It doesn't help us actually. So generally we want to take different inputs, different values from the user and store it in an array. Okay. Now instead of using a constant, I am using an expression here. This expression is evaluated runtime during the execution. So this is generally we consider it as a runtime initialization. The loop will, in fact, compile time only compilation happens. The execution of the loop multiple times, 3 times or 4 times happens during the execution time or runtime. So that's why we call it as runtime initialization. Compile time, typing the code, compiling it, and generating the executable file. But we are not executing it. That much is compile time. But when we are executing, we call it as runtime. So these are two phases actually. Even though it looks like we are doing together, we are not in fact doing together. We are compiling and we got the executable file, and then we are running the executable file. So when we are doing this, we call it as compile time. If we are assigning something, or we are doing in something here, typing the code and modifying the initial values, that are all compile time. So after compilation, when we are doing running execution, actual execution happens in the CPU. Okay. Now this is what runtime the basic runtime initialization, which is not so useful. The actual runtime initialization will be helpful only if we are taking the input from the user. How do we do that? Well, this looks little okay. Yeah. So what is that I am doing here? I want to take the input from the user. So I created the array, and within the body of the loop, and I have a loop here. Within the body of the loop, I am taking a input from the user. Enter number, scanf %d. I am storing it in a temporary variable. I created a variable, whatever input. The user is going to enter a number, and that number I am assigning to a of I. Number I am assigning it to. Now first iteration of the loop, suppose user enters, so I is equal to 0. User enters 5. Whatever user enters, assume that it is 5. A of 0 will be stored with 5. And this loop will be executed one more time. Second time 10 will be entered by the user. I am assigning it to this a of 1. I is incremented to 1. So in the second element of the array, I am assigning 10. Third time maybe user enters 15. So temp will take the value 15 now. The new value 15 will be assigned to a of 2. This way we are going to initialize. Okay. So this is what runtime initialization. We are going to see a real example of that. Real example of that. So we will take a small array and size of the array. Let's let it be 5 for the time being. Now we need to create for since we have to use a loop, we need to create a index variable. You can call it as index or I, just to reduce the typing effort. I am using index variable. So what I do is for I equal to 0, I less than or equal to or less than. I will take a number. Now one more thing, if I'll just take it, go there. So these two statements I can combine. In fact, I don't need to use a temporary variable. This line number 1 and line number 2, I can combine it this way. Instead of you taking the variable into a temporary variable, then doing an assignment, instead of that, I can directly put here ampersand a of I. Okay, same effect. A of I is one variable in that array, and since I am scanning, I am using ampersand. When we are scanning input from the user, we use ampersand before the variable. So A3 is a collection of three variables. Out of that, A of I or A of 1 is one variable, and I am storing a variable into that. Because of that, I am using scanf. So what I am going to do here is scanf. Same thing I am going to do here. %d ampersand A of nums I. Okay, here prompting message I will put here only once. Every time, no, instead of not putting prompting message every time. So enter 5 numbers. Okay, now we will, let's see, it's compiling. Yeah, it's compiling. We'll try to debug this and see what happens. We'll take the watch window also. So nums is created here. See, it is executed till now. It is executed. We are here now. Okay. Now we have an array here, and it has some random values. See, 0 indexing. The nums array is shown here. 0, 1, 2, 3, 4. Nums of 5 is not there. Nums 5 is not there. And that is the same reason I am giving I less than 5 here, because my index value should start with 0 and the last valid index value is 4. If I put I less than or equal to 5, for I equal to 5 also it is going to execute the loop body, and I will get something nums 5. Nums 5 is not a valid location in the array. Because of that, I use I less than 5. The maximum value valid legal value of I should be 4 only, or the maximum value for which the loop body should be executed is 4 only. Because of that, I am putting I less than 5. I should not put I less than or equal to. This thing you should remember. Now all the variables are having some random value. Since I did not initialize any value, all the variables are having random values. So I am going to continue execution here. 0 less than 5 is true. See, I value is 0, that is true. Scanning. So what I am doing is I am going to enter my first number, maybe 5. I press enter. I have come out of this scanf statement, and first element, whatever number I stored, it is stored in whatever number I entered, it is stored in location 0, num 0. So I will continue this. F7. Second number I am entering, so maybe 10 or little different number. I will put 6 or 6 or 11. So if I come back here, A of 1 11 is stored. Okay, I am showing the memory actually in memory how it is stored in the array. So this is the watch. We are watching the memory how it is populated. Okay. So again F7. Next number. Maybe I'll put 13. If I come back here, 13 is stored here. I is equal to. So I is going to increment to 3 now. Here increment happens immediately. Checking the condition happens, and if condition is true, we enter here. So these things happen simultaneously. We cannot split them and see. So we reached here I is equal to 3. Next number 20. So whatever value was there previously, it is overwritten. So A3 is having now value 20. Okay. So one more time 24. So all the numbers I entered are, so these are the numbers I entered 5, 11, 13, 20, 24, and you can see at 0 first element 5, then 11, 13, 20, 24, and we are not processing the data as of now. We will process it. So we are just focusing on the input. Now this is how we take generally into a program multiple amount of data, large amount of data, say 10 integers or 50 integers or 100 integers. This is how we are going to take into our program. So we will this program will finish here. So we are out of the program. So is it clear? Visually you have seen what exactly happened when you create an array, what exactly happens in the memory, and how we populate the elements numbers into the array. This message I have taken out just to keep it simple. This message should be printed only once. That's why I just uh, took it out, and only scanf statement is put within the array. So this pattern is what you have to remember with respect to arrays. We are applying loop, populating one element at a time into the array. Now what next? After doing this, we have to uh, populate process this data. So simply storing numbers into the memory doesn't help. So we have to process it. So we have to do processing. Now I'll just make it little bit general. This program will always take n variables, five variables, five numbers, five numbers. I want to make it general. I want to take n inputs into my program. So what I can do, I can ask the user enter the value of n. Then I can store it in n. Okay. So this program, now my boundary I will make, instead of 5 I will make it as n. Previously I was sure that only 5 variables are going to be there. Now whatever user, how many numbers user wants to enter, that many numbers he can enter. First he will tell, okay, this is the maximum numbers I want to enter. This many numbers I want to enter. So n is the number of numbers user wants to enter. Then based on that we are reframing our loop. Instead of making I less than a constant, I make it I less than n. So I will take the value 0 to n minus 1. That is n values. 0 to n minus 1 means n values. So n values user can enter now. Now only one problem is there. My array size is 5. If user enters 10, I cannot store 10 variables because my array size is only 5. So for that what I will do is I will assume a maximum value. Maximum user is going to enter only 100 elements. So assuming that I am going to create an array, or I will make it slightly smaller. Maximum 20, my assumption or prior understanding or knowledge of the program is that user is going to enter only maximum 20 numbers. So I create an array of maximum size maximum possible size user may enter. So based on that, I create the array, and now I take an element number from the user. So user can now enter value of n, anything between say 0 to 20. Anything between 0 to 20 user can enter. Okay. So sometimes user may want, so here I will do, what I will do is I will make it percentage %d comma n, percentage %d comma n. I will compile this. Hopefully it is working. So enter the value of n. Suppose I am entering 7 numbers. My array size is 20, but actually when I am executing the program, I want to enter only 7. So I can enter any numbers between 0, any number of numbers between 0 and 20. So at this point of time, I want to enter only 7 numbers. So I'll put 1, 2, 3, 4, 5, 6, 7. I'm not processing that. Simply it is stored. That's it. So if I debug this program, see nums is now size of 20, starting from index 0 to 19. Nums is size of 20. Some random values are there. Now if I keep executing, I'll put a breakpoint here and I'll directly continue rather than going step by step. So I can continue. Continue means without going step by step, it will execute. So if I want to enter 6 numbers, 6 numbers I entered. 2, 4, 5, 1, 5, 7. These are the 6 numbers I entered. Now if I go, the break, I had put a breakpoint here, so it has stopped here. I will go and see the array elements. 6 numbers I entered, right? 2, 4, 5, 1, 5, 7. All the 6 numbers are stored. The remaining locations, some random values are there, which means out of 20 elements in the array, I am just using 6 locations, 6 elements. Sorry, 6 elements. Index 0 to 5. It is fine to leave them alone. Leave the rest of the elements in the array alone. Just that. Next time when I am executing, I may choose for entering 12 numbers. So at that time 0 to 11, index 0 to 11, 12 elements will be utilized. Okay, it is okay to create a reasonably sized array and using a part of it. That is what I am doing here. 20 size array, size of the array is 20, but I am using only 6 elements. Okay, next what we should do is we should start processing the data. So declaring an array or creating an array, initializing or taking data into the array we have studied. So processing this, again we will have to apply loops because our elements are stored in the array. Instead of individually accessing using constant indices, num0, num1, etc., it is better to use a loop there also. That we will see in the next class. Okay, we will stop here and